Yeah. Which is it? Which is up to you. Perfect. Fergus is going to be presenting Futures Thinking today at Dstl. Thank you so much, Fergus.
No, my pleasure. Can you all hear me okay? Right, I just checked the clicker's working. It is amazing. Right, so yeah, good morning, everyone. Really lovely to be with you again this morning. And I think I put my hand up. I don't know when was it? A meeting about a year and a half ago when Imo asked about my view on futures or our view on horizon scanning, and I gave my view of the world, which maybe caused him to think to invite me to speak about it in a bit more detail. So that's why I'm here. Last time I spoke about wargaming and about various other sort of gaming approaches in Dstl. I touched on futures, but I didn't quite get through some of the slides that I hoped to. So today, it's just really an opportunity to talk to you about some of the things that we do in Dstl when it comes to doing horizon scanning and futures work. I'm really grateful to Bill, who's joining me this morning, and he's going to talk about some of the work that Cambridge consultants have done for and with Dstl as one of our strategic suppliers and a key partner in doing this work. So I'll cover a little bit about Dstl. I'll give you a few slides and just an update about where we're at, because we have changed, I think, since the last time I shared with you. And I'll give you an update on the National Armaments Director Group as well, just briefly. Then I'll touch on our science and technology futures program and how we do futures in terms of the broad methodology. And then I'm going to come on to allow Bill to speak and give some examples from the work that they've done. And if we have time, there's some stuff on traps, cognitive traps, and issues around using language around uncertainty and how we describe uncertainty in government. So let's see how far we go. We will hopefully have time for questions at the end as well, but if you've got a burning one or something really doesn't make sense, please pop your hand up and I'll try and address that as we go. All right, so I did share last time an overview of Dstl, so I won't repeat myself too much, but just as a quick refresher, and this is me, I should have explained my role really, shouldn't I? So essentially I look after our strategic relationships with academia, with industry, with other government departments and international allies. And we do that because we need to maintain an understanding of who can deliver science and technology for us and with us. And we need to understand the capabilities that others have. So my role is really to stimulate the external environment outside of government to really prepare for the future and develop the capabilities that we think we will need to have the winning edge. So that's really my role. And I also serve as deputy head of our delivery partner engagement function as well. So just a very quick reminder about what Dstl is here to do. Dstl is part of the Ministry of Defence. I'll explain that in a bit more detail in a minute. But essentially, we are here to provide the science and technology, engineering, analysis work for the MOD. And we do that not only by using our own resources, but more than half of it is with our partners in industry and academia as well. Over £500 million is spent and invested with industry and academia every year. We are really focused on making sure that we do have and we enable an operational advantage. We want to prepare for the future, which is a bit I'm going to talk about today. We also have an analytical capabilities to make sure that we can shape the defence and security landscape, inform decision makers, whether that's the Prime Minister, whether that's the National, whether that's the Joint Intelligence Organisation, or whether that's the Ministry of Defence or any other part of government. We want to be able to shape and inform those organisations. We have a whole lot of business enablers as well, of course, and we have a set of international relationships that we use and leverage to make sure that we can have the highest impact. These programs are slightly out of date, but I don't want you to worry about the detail. I want you to think about the fact that we have within our portfolio what we call driving, responding and servicing programs. So there are those programs within the portfolio that are much more of an S&T push, if you like, and there are those that are much more responding to user needs. So I'm going to talk about the Futures program today in context of that portfolio, that we have some programs that are pushing science and technology into MOD to say, did you know that science can do this for you? quick word on our new delivery partner engagement office. This is a new dedicated business function within Dstl that essentially has given us some dedicated resource, actually that was quite badly needed, to make sure that we can really focus on working with delivery partners, and that's where I now sit in the organisation. It's a dedicated function. As I said, it focuses on sort of more transparent communication. We've been sharing information with our partners on our budgets with more detail, also how much of those budgets are for extramural research and how much is not committed, so you can bid for, encouraging you to sign up with our commercial frameworks, and making sure that we can drive better value, so we can share with you what we think our challenges are and where we think we want to go. So that's really the purpose of the organizational design element that became the delivery partner engagement office. We have restructured the way that we deliver science and technology in Dstl. So we have new science and technology teams. I won't go into all the detail here, but the thing to know is that you can come through the DPE office and we will help you navigate this, because I know that we can be impenetrable at times. But we have strategic capabilities where we own a sovereign capability plan for the UK in certain technology areas. You can see some of them listed here, not all. And we brigade our people, around 5,000-ish, well, no, about 3,500 people in these teams, into these different S&T areas. Happy to talk in more detail about these if it's of interest, but I want to sort of press on to the features slides, really. So what does this all mean then? Really, Dstl is making a large investment in science and technology. We fund a lot of the early development that really leads to new defence capabilities. We enable companies to develop, I hope. We give direction in terms of skills, facilities and IP. We don't always keep the IP. We want our partners to own the IP in many cases, which ultimately, hopefully, leads to better capabilities, at least to prosperity, and also the growth of skills and particularly STEM sweat that we need to solve these problems. Okay, so if you're not aware, defence has been going through a thing called defence reform. It's a huge, sweeping, significant change that really will empower and enable a more efficient and impactful defence system. So previously we had something around 16, 17 senior decision makers in MOD, and we've simplified it down to a quad of 4 areas, which is really the Department of State, the military strategic headquarters, and the defence nuclear enterprise, and then all of the enablers, and that includes science and technology delivery, are now grouped together, helpfully under the National Armaments Director Group. So what that means is that there's a single group where we have only 3 budgets in MOD. We have an invest budget, which sits in the NAD, and we have an operate and a readiness budget. So it's a much more simple model, and we are currently going through a process of integrating all the various parts of the NAD group together. So that's a key structural change. What it means in real terms is that the frontline commands, like the Army and the Navy and the Air Force, they don't have the money anymore in terms of commissioning research directly. What that means is that they will share their key problems into options and commissioning in the NAD group, and that options and commissioning will then flow through into a set of portfolios that we will deliver against. So it's a significant change. I'm happy to talk more about it, but again, I just wanted to give you the wave top view so that you understand what's happening in defence reform. As I said, there are a number of organisations: international collaboration and exports, commercial, options and commissioning I mentioned as a new organisation. Innovation was mentioned earlier. We have a new UKDI organisation, a 3-star led organisation now, which will form part of the structure of the NAD as well, sitting alongside delivery. So this is what forms the NAD group. So when you hear that term NAD, effectively think all of MOD's enablers in one big area, around 27,000 people, and we look after more land than Devon, I understand. So it's quite a significant enterprise. Okay, I'll flick on. So just to summarise then, so Dstl is the MOD's in-house laboratory, if you like, part of the NAD group. It's one of the key organisations that delivers science and technology and invests in academia and industry to do that. We provide specialist services as well that you can't get anywhere else, and we are around 5,000 people strong. So that's just the way top view. All right, if you do want to know a bit more about how to work with Dstl, you can take a shot of that QR code and it will take you to a page, a .gov web page, which will detail some of the frameworks that we use, the programs that we have, and some key points of contact. So please do that. Right, I'm going to get on to talking about futures, which is really the main focus of today, isn't it? So defence science and technology futures. I guess the first thing I want to say is there are a range of disciplines that we use when it comes to futures. It's a multidisciplinary enterprise. We have, as I mentioned, we have all kinds of scientists in Dstl. We have engineers, we have analysts, and we've drawn on a range of different approaches to think about the future, to explore, to discover, to search, to assess, and analyze. And so you can see some of the key things here. This is not an exhaustive list, but I just thought I'd pop this up to make the point that actually this is not just physicists and chemists doing horizon scanning. This is actually a multidisciplinary approach, and we find that that is the best way to solve problems and come up with new ideas. This is an old slide. It's a really old slide, and it probably goes back to sort of 2020, really. And I've been working in futures for many years in government, going right back before the SDSR 2015, and we've been saying the same thing. But the thing is, it's still true. So the world is changing, and it's changing rapidly. Technologies are accelerating in some cases. The S&T landscape is changing constantly, and the national strategic direction back a few years ago was very much to emphasize the need to understand the future and pull through emerging technologies. That hasn't really changed. What we have is some new structures. We have UKDI that stood up to focus on that pull through and addressing the valley of death particularly. But Dstl remains positioned to do much of the work in this space. So an old slide, but some of the messages are really the same. So what is our job then? Future thinking today. So our job is to anticipate the future. We cannot, unfortunately, predict the future. I really wish we could, but you really can't. And in the minute you think you're close to it, you're probably a mile away. So we can't predict the future, but what we can do is we can forecast a range of credible futures. And that's really what the program is trying to do. So we want to find high impact, high uncertainty science and technology, new concepts that are probably alien to many people in defence. And we want to present these findings to key decision makers in defence to help them understand why it's a game changer. Why should they care? How will it manifest? What will it do in society? And so what we do is we exploit that into other research areas, directly into stakeholders and into academia and industry as well. And so that's what we mean by futures thinking today. I mentioned the research portfolio. And so if you think of as futures as a stimulus, really, and we look at sort of uncertainty of capability integration as a function of uncertainty of application, we've got a range of different programs that sit on this chart. And really, Defence S&T Futures is the top right-hand corner. In other words, it's the most uncertain, and really it's the riskiest 5% of the portfolio, I suppose. MOD thinks of it a little bit like an insurance policy, and I'm not sure if that's actually the right way to think about it, but it's trying to find those things, those blind spots that we could be really hurt by, but also that can really have a huge effect in terms of the national prosperity and game-changing science applied not only in defence but across society. So it's a very much an S&T push, as I said. So just to kind of summarize then, so our job is to consider the future. We want to find the high impact stuff, so it really has to matter. We want to find the high uncertainty stuff, the things that because actually my own personal view is that where defence has been surprised in the past, it hasn't necessarily been a new technology that we've found, because we're reasonably good at finding new technologies. I think where we're surprised, it's often to do with the way that technology will evolve, or the socio-technical system that it sits in, the behavior that goes with that technology, how society accepts or doesn't accept that technology, what it means on a platform or in a system. That's where we get surprised. And that's because it's harder to model. And we do try to model some of these things. But actually, as I said, finding the technologies is one thing, understanding the implications is another. And I think the real challenge, as I'll come on to, is about, it's not the gathering of information, it's the filtering and the triage and the interpretation of that information that is the challenge. So the way that the Futures program works is that we effectively go from a sort of identifying concepts through to developing the idea and then producing a case for change, and then hopefully transitioning that into a range of opportunities. I mentioned before, it's not really prediction, and then really it's not really forecasting either. It's about having foresight into the future and some intelligence into the future. Okay, I'm going to skip over that. I'm going to give you an illustration. So if we think about a radar, there's a couple of things here that kind of stand out to me as a useful illustration. A radar has a 360-degree view, and when we come to our domain of interest, we have to have that 360-degree view. And also, the radar refreshes itself regularly, doesn't it? So we must constantly refresh the data that we are getting and that underpin the judgments that we're making. And so if we look in a certain area and we've made a judgment that a certain technology is not that important, when do we make a reassessment of that thing? When do we go back to it? And I think, we need to constantly refresh and go around that cycle and not just assume because we judged something 2 years ago to be not important that it isn't important today. What if there's been a new enabling technology that completely changes our assessment of that thing? So there's something about having a 360-degree view looking in all directions. There's something about refreshing that information. And there's also something about how far out we look in terms of the horizon. You don't just want to look at that inner circle. You want to look out as far as you can so that you're not surprised by things in the future. And also with a radar, you have a gain control, and that filter is really, really important because as you turn that dial, you're either going to be overwhelmed with information and you can't manage it. And maybe coming back to the point around AI, this is where we can be smarter. Or you can find better ways to triage and filter and assess. So I hope that makes sense. So what do we mean? So what do we mean by things? Well, in searching, and I think when we talk about technology watch particularly, we are describing what it is we're interested in before we look for it. So I know that I'm interested in, I don't know, autonomous systems. So I'm going to look for autonomous systems, and that's fine, but I would describe that as tech watch. But in scanning, what we're doing is we're looking for the unknowns. We're not necessarily even using those terms. We might use a more general seed term like, I don't know, privacy enhancing technologies or something like that, something that's general. But we are hoping to find things we don't know about. So in scanning, it's more speculative. It might be controversial. It might be completely unrelated to defense. We might use terms like world changing or game changing, something like that. So that is how I see the difference between TechWatch and horizon scanning. Really is one is looking for things that we kind of already know about, or we have at least an inkling about that we have an interest in, and the other is really looking across that horizon, as I said, like that radar, for things that we just don't know is out there that we need to interpret. Okay, a quick word on threats. Clearly, when we're doing futures work, we're identifying both opportunities and threats, and sometimes they are sort of two sides of the same coin. If we think about the top left-hand corner here, this image is from the bouncing bomb. Is everyone familiar with the bouncing bomb from the Second World War, Barnes Wallis, 1942, I think it was? One thing that you may not know is that H.G. Wells wrote a book. I think it was called The Shape of the Future or something like that. He wrote this piece in 1933, which described something very similar to a bouncing bomb. Now, I would argue that had, in this case, in the Second World War, had the German military scanned that information, they might have predicted that the bouncing bomb was a disruptive technology that could have been developed. And I would also argue that the bouncing bomb was a bit of a game changer. what it meant in terms of the Ruhr Valley, wasn't it? Was that it gave us a significant advantage to the Allies. So I think that was a failure of imagination. And actually, and interestingly, it came from fiction. And how often do things come from fiction that stimulate our thinking and our imagination? When it comes to innovation, I would argue also that we need to stimulate our imagination. And often working in defence is probably the last place you need to be imaginative, unfortunately. So yes, the bouncing bomb, an example of something that was written about in fiction, that was developed in reality in the 1940s, and was not picked up or predicted by the Germans in the war. So I think that's interesting. So there are threats that come because of a failure of imagination, and then there are some threats that are nothing to do with new technologies at all, but are actually a new idea, a new concept of operation, a new way of applying things. And we look at 9/11, and unfortunately, that wasn't predicted either. So the use of an aeroplane as a weapon, it was the concept that hadn't really been fully understood or mitigated. And so that wasn't a new technology, but it was a new threat, wasn't it? Back in 2016, there was a really horrible and horrific terrorist attack in Nice. I don't know if you remember this. It was a vehicle attack. 86 people died as a result of that dreadful situation. But it was not the first time that a vehicle had been used as a weapon. In 1973, that had been done in a terrorist context, going all the way back to the Second World War, actually. But the thing is, people forgot about it. And after Nice, unfortunately, other bad actors were inspired by that way of operating, and they themselves, and we saw that, didn't we? We saw that in London, actually. I was there on that day, that the Westminster Bridge attack, and one or two others. So this is the threat that comes really from things that we forget about. What have we forgotten about in our research that we might need to come back to? Right, I'll move on for the sake of time. Okay, so how do we find what we are not looking at the moment? And we've got a number of ways of doing that, and I know Bill will touch on this as well. But we take information from a range of different sources. There are lots of sources, and we really then have to review and assess and find new areas of research to investigate. We have to encourage our own staff, I think, to as well as our stakeholders, to do that, and we have to keep an open mind that no idea is too out there for us. You know, there are areas of unconventional science which I guess are uncomfortable for some of us. And in some cases, it's almost, many times that things have been dismissed. Oh, we've looked at this years ago. It's not credible. Maybe it becomes credible. So there are a number of ways that we do that. And as I said, I think the taking on board all the information is one challenge, gathering the information, but looking at how we filter that, whether it's a simple framework like TRUE, or whether it's a very sophisticated technology, whether it's using AI or something else, we still need to think about how we do it. The TRUE framework is where you look at whether something is timely or relevant or unfamiliar to defence or exploitable to defence interests. So the way that the Futures Programme works is it uses a hypothesis-led approach. So it's very, it's really the scientific method just adapted in a futures context, really. And so what we're trying to do is answer these high-level questions. I mentioned a few just then, but there are other questions. Why should we be interested in this thing? Why does defence care? Why should science and technology get involved in it? And why is it of interest now? Maybe it's something that needs to, be just monitored. And so these are the things that we need to think about. And then ultimately what we want to do is produce a case for change. If there's something out there that we need to look at, what's the case for change? What's the evidence that we can build to build that case for change? So we do that through ideation, developing hypotheses, testing them as much as we can, and then building that case for change. This is a little bit more detail on that pipeline. So essentially what we have in the Futures Programme, and this is a little bit out of date now, but the principles still apply, I think. That effectively we have an engine room that has a number of maturation stages in it. And then what we want to do is to take the concept and effectively mature it. and so that we have a greater level of understanding as we go through. So as I said, we start with a concept definition, we then go into concept development, maturation, and then if we can, we want to, if it passes those stages, we want to then assess the thing in some way. And perhaps that means commissioning research. And then we want to think about how do we transition that into our portfolio. So these are the sort of the large steps, I suppose. All right, I'm going to hand over to Bill fairly soon, I promise, Bill. But just some guiding principles before I do, just some things to think about for futures. So in many cases, much of the work that we do in science and technology is driven quite rightly by user need, by user problems, by strategic problems and challenges. And that will remain the case. We still need to do that. There's nothing wrong with being led by user problems. But with futures, what we want to do is to have the freedom to start anywhere. And we can be inspired by problems, that's great, but we might also be inspired by something else, by the art of the possible, by a new exciting area of science. So that's important. I think what we also want to do is to build in partnership by design. I'm very, very aware that people that work on futures in Dstl or in defence or in government even, we are all brainwashed into being government people. I'm a lifelong sort of civil servant. Well, I have worked in industry, but, you know, I'm a career civil servant. And so I think a certain way. I want to be able to access expertise, diversity of thought, different opinions, disruptive thinking from the sorts of people that quite honestly wouldn't necessarily pass a security clearance for, because we want people to think differently. So I think there's something about partnering with a range of different organizations and individuals so that we can foster that diversity of thought. We don't have a monopoly on the good ideas. We also need to have a different risk appetite, and to get timely insights, we need to have a different risk appetite. I may have mentioned last time, the world is changing, and unfortunately, the threat landscape is becoming, is broadening, is deepening, it's becoming more complex. And unfortunately, the threat horizon for certain scenarios is coming nearer. So what that means is that we have to be really honest with ourselves about how long we should take to do things. And so we need timely insights, and therefore we need credible futures to assess these scenarios against. And we also need to understand actually what the implications are. Sometimes it's a threat, sometimes it's an opportunity. Sometimes it's not something for defence, but we know that it's valuable to us. And a few other final guiding principles. Context is really, really key. I've mentioned already the socio-technical system, and this is my own view of the world, but I find it really interesting that most of the things we're surprised by, it's not the science, it's the behaviour that goes with it. It's a human science we need to get after. It's the legal and ethical applications. It's the system readiness stuff, you know. These are things that we need to get better at. I could give you some examples. I won't for the sake of time, but there are some really interesting examples of technologies that have come up where we've got very excited about it and thought, well, we're going to do this, this, and this, and then the general public does something completely different with it. So that's really interesting. And then sometimes there's a role for futures to myth bust as well, to say, no, this is just not a credible thing. This is not something we should be getting involved with or investing in. And then the last thing is about influence. The thing about futures is it doesn't really make any difference to anyone unless you can persuade a decision maker that the thing matters. So building compelling narratives around why this thing is going to be a game changer, why should I care about it, is really, really important. So for that reason, and I mentioned H.G. Wells before, for that reason, we've got involved in all sorts of things that you might think are slightly odd for a defence science and technology organisation to do, like writing fiction, producing videos, producing games, tabletop games, producing AR and VR environments for us to experiment with. So these things matter because it helps decision makers understand why we should care about things. All right, almost there, I promise, Bill. So the way that we do this is we pull all this information into different dashboards. Is a kind of mocked up example of the kinds of things that we might include. So we might have something like a high level description of the thing. What is the concept? What are we talking about? Why is it important? We might have something that specifically talks about its relevance to defence and security. We might talk about the stakeholders and how it would align to our portfolio. We might talk about how it impacts strategic capabilities or different technology areas. And then we'll think about things like, what are the industry drivers for this thing? Can we rely on industry to develop this, or is it something we need to develop in-house? We'll think about technology readiness level and whereabouts on that pipeline the thing sits. It might be an early idea and it's right at the ideation stage, or it might be something that's actually really about concept testing. So just wanted to flash this up. We could, if we had time, get into a little. We could sort of bring this to life a bit. Here's a very quick sort of redacted example on teleexistence, just to show you what that might look like. But for the sake of time, I'm going to flick over the example and I'm going to hand over to Bill, and Bill is going to talk about the horizon scanning and technology convergence work that Cambridge consultants have done with us.
Good morning, all. You can see from this first slide, I'm very much not Dr. Heidi Pinkney. She sends her apologies. She was going to be giving this talk, but she's down with COVID, so you have me instead. So I'll get my excuses in early. I'm very happy to take any questions you might have, but please do excuse me if I need to refer you onwards after the brief. So just to give you a bit of a calibration before we launch in. Cambridge Consultants. We are a company that came out of the university here in 1960, and our founding mission statement was to put the brains of Cambridge University at the disposal of British industry. Or in slightly less grandiose terms, to put emerging technology to work. And this was a time when the idea of connecting, building stronger bridges between academia and industry and government counted as a pretty new idea. And we were in at the start of what has turned into the ecosystem here in Cambridge with the jobs and the world-changing innovation that's created. The other thing, just to calibrate you on Cambridge Consultants, is 1960 was a time when the word consultants meant something different to what it means today. So if it conjures images of reports and analysis, yes, we do lots of reports, we do lots of analysis, and I'm about to talk about some of them. But most of what we do is build things. We're a technology consultancy. We've got labs, we've got workshops, we've got data centers, we've got anechoic chambers. We build products and services and systems, and all of the advisory side of what we do, the classical consulting, that is the meat of what I'll get into, is all built on the fact that we make things for a living. So I'm going to go a little bit further than Fergus in terms of what you said about we can't forecast the future, but we can try to come up with a range of plausible scenarios. I'm not sure Lincoln ever actually said that. He probably didn't. But in the national security context, particularly as we've just been hearing, the best way to predict the future is genuinely to create it. Because in the defense and security world, if you're reacting, you're probably losing. And people are probably getting hurt. So, what do we do on the advisory side of life at Cambridge Consultants around horizon scanning and technology futures? Given what we do for a living, which is to put, as I say, emerging technology to work, to take ideas that come out of universities, of research institutes, and we're neither of those things, but to take those ideas and translate them across the legendary valley of death into things that are going to have operational, or for our industrial clients, commercial benefit. We have to know what's on the horizon. And to summarize what's up on the slide there, and I won't read it to you. Our philosophy around horizon scanning, technology watch, futures work, falls down to so what? We're not in the business of collecting information about technology for its own sake. We're in the business of collecting information around technology to serve a set of purposes. And I've got some examples of the sort of thing that Fergus and the team at Dstl have asked us to do in the past in a moment or two. Sometimes that's a very broad definition. Sometimes it's not, which makes it rather easier. But we always try to focus on the so what. So if you're looking into the future around whatever the technology of interest is, what are its implications? What difference is it going to make to, in the context of this talk, national security? What opportunities does it present? What new threats does it open up that one has to mitigate? Always focused on the so what. Start with why, always. So here's how we do it. And I'm sure there are plenty of people in the room who are in the business of horizon scanning and technology features one way or another. And a process chart like this won't be unfamiliar to you. So understand, ideate, analyze, and communicate. What I'd call out from the 4 blocks you can see on the chart there, in our experience, it's almost impossible to put too much time and effort into the first one and the last one. As I say, some of the questions we get asked, I'll illustrate in a moment, are very broad indeed. And the more time you spend in reconnaissance, the more time you spend in pinning down as best you can the question that you're trying to answer, the so what that you're trying to serve, the better. At the other end of the flow, the communicate, well, Fergus has already talked about this a little. The audience for the sort of work we do in the defense and security world can range from a deep technical specialist in Fergus's team at Dstl, a genuine world expert in quantum compute or whatever it might be, right through to an advisor in number 10, who probably has less technical expertise in quantum compute. And finding ways to take complex technical ideas that can serve that range of audiences, again, is something I would argue you can never put too much time and effort into. So the sort of thing that Fergus was talking about, writing science fiction stories, and the work we've done for Dstl, we've made action movies to try and get complex ideas across to non-expert audiences so that they really can see the so what. They don't need to know how the quantum computer works, but they need to know what that means for internet security. So there's the same thing laid out as a flow chart. And in terms of action, how we actually do it, as I say, upfront, understand, pin down the question as best you can. Ideation is the getting hold of the information that you're working with. And I've been working in this space for an awfully long time. And time was when actually getting hold of the information in the first place was your problem. You just didn't have enough to work with. That's changed utterly, of course, obviously, over the course of the last couple of decades. We're seeing that the woods for the trees is the tough part. And what we've done with that over the course of the last 5 or 10 years is increasingly use artificial intelligence as an aid to gathering and sorting through the data that we're using as part of our horizon scanning activity to take a broad scope, to take the information that goes with that and narrow it down effectively. When we use that to feed a team of human experts, some of whom are drawn from CC, some of whom are drawn from Dstl, from academia, from industry, to begin to sort through this prioritized list that flows from the search for data to say, actually, okay, the machine's saying this, the machine's saying that. What do we think about this? What do we think about that? Where should we prioritize? Where should we really focus? Where are the issues where are the technologies that really answer the so what question that I'm asking here? And then on into the stakeholder engagement. Having done that analysis, having understood what that quantum computer might mean for internet security, how would you begin to get that across to the range of audiences that you might have involved? I mentioned that we increasingly using AI tools. We started looking around for various tools that we could use. Crikey, 4, 5, 6, it's going there. We didn't at that time find one that we actually liked the look of to serve the full range of needs that we have, particularly until through a contact in the UK national security community, we came across a small company called Graphium, who had spun out of the university in Swansea. They'd been working on a document management tool in a national security context for a number of years. But completely AI driven, that met our needs perfectly. It allows you to take a body of unstructured, a large body of unstructured text and begin to distill out not only what phrases are coming up the most often, but themes around them. So I think did thematic analysis, which is really the thing that we were looking for to be able to answer the so what question that I've been rattling on about. And well, ultimately, as it says up on the slide, that we like, as the old advert said, we liked it so much we bought the company. And this is certainly for when we get asked really open questions, very much the front end of that ideation part of the work that we do in horizon scanning. It lets us get our arms around huge bodies of information, quickly distill it down and focus the expert insight that I've just been talking about, the humans, on the bits that we believe really matter. So, some examples. So, this was work that we did on behalf of Dstl and a number of other government departments in horizon scanning with a scope across the whole STEM. Talk about open questions. So the exam question we were asked to answer was, please tell us about the technologies that are going to emerge in the next 5 or 10 years that have implications for national security. Wow. That was a biggie. So as you can see from the slide, we worked through the 4 steps in the way we go about doing these things. And it was just a massive prioritization exercise. Went through our understand step, worked with our toolkit, worked with experts drawn from across the community and outside the community, drawing in alternative points of view to compile a long, to start with, it was a very long list of things that we believed were going to matter. Turn that over to a group of experts to go through that long list and begin to prioritize in a systematic, rigorous way, and had a particular process for the way we went about doing that. But distilled out basically something like 100 different topics that we felt were the most relevant, the most important to the set of national security use cases that we were dealing with, which we're going to have the most impact in either a positive or a negative way, or potentially both. And that led in turn to a whole bunch of reports, both on individual technologies across the physical, digital, biological domains, but also as time wore on, the convergence between them. What happens when AI meets engineering, biology, that sort of thing. And communication, well, that's where we ended up not only writing reports, but making sorts of videos. And this is, well, by the time we'd done 12 of these over the course of the year, that's where our action movie came from. We tried to take all these 12 sets of technologies and put them into a single video that you could park in front of almost anybody, and they get the gist of what this was about. This is more technology watch than horizon scanning. So this flowed on from horizon scanning work that was done a number of years ago for the Dstl. And this, unsurprisingly, I guess, was all about artificial intelligence and trying to spot what was coming out of universities, what was coming out of companies like Graphium by way of new and emerging AI techniques that, again, had potential implications for a set of, and this was specifically defense use cases. And it was absolutely fascinating to see, as we've been doing this for many years now. And seeing from a personal point of view, seeing what has now turned into what are called large language models these days, but seeing the germ of that 7 or 8 years ago and what it's turned into today, and tracking that through a technology watch activity and pinning it against a set of use cases in the defense context, absolutely fascinating. And finally, I talked about convergences coming out of the horizon scanning work that I mentioned at the start. That became such a theme in the first piece of work I talked about, that we actually did, we've been collaborating with Dstl on a completely separate piece of work that builds on that, that deliberately sets out using the AI toolkit I was talking about to look for new convergences of what technologies on the horizon, about 10 years out or so, that might conceivably knit themselves around each other in one way or another to have implications, again, in a defense context. And as you can imagine, that's such a corpus of information that you have to wrangle, that actually doing that without machine assistance is tantamount to impossible. And that's really at the heart of that piece of work. In each of the 3 examples I've cited, the so what, if you like, beyond what I've already been chatting about, there's been the ability to do some of the things that Fergus mentioned, which is make decisions about future investments in science and technologies, to make policy decisions about regulation around AI, whatever it might be. So if I've got one thing to say to everything that I've talked about and the work that we've done in support of Dstl, it's predictably enough, start with why. Thank you.
And just to underline, the work that Bill and his team have done for us has been really, really valuable. In some cases, it's led to new projects as well as sort of being a sort of purely transactional thing. The convergence area is a good example. I think back to operations in, say, for example, in Afghanistan, where we were dealing with IEDs. We were using things like general morphological analysis, so key matrices to try and identify combinations of things, and we've gone so much further using some of these tools. So that's been great. I think we have a little bit of time left, so I could ask for a vote, actually. I've got a couple of things we could do. So last time I showed you a video called Gloria. For those that were here, do you remember the video? Anyone remember the video? We have more of those. So I have another one of those videos. You're welcome to see that, or in the break, I can show you that. Or we can have a look at some more stuff on gaming, or we can have a look at how we deal with probabilistic language. What do you think? Is any strong feelings about what you'd like to hear from? Okay, all right, okay. No problem. All right, so thanks again, Bill, for that. Really, really inspiring stuff. So I'm going to flick on from some of these things. We talked about fiction, by the way. Just quickly mention, I think I mentioned this last time. We have commissioned a range of short stories. You can download these. They're really, really good, very well produced, excellently written by US authors who are also senior fellows in think tanks in the US. Really recommend that. I can give you a link for it. Right, let's move on to skip the gaming, because we kind of did that last time. And I want to talk to you for just 5 minutes, then we'll have some questions about uncertainty. This whole issue of how do we describe uncertainty. And the PHIA yardstick is something that was driven out of the professionalization of intelligence analysis in the Cabinet Office, in the Joint Intelligence Organization at the time. And so I thought I'd just talk you through some of these concepts, because I think they're quite useful. I'm going to skip over the Italian flag. This is also a very good model, but we'll come back to that another time. If anyone's interested, it's an Italian flag approach. Anyone heard of that? Familiar? Yep, okay. I'm going to skip over it for today, though. But a bit of background in terms of probabilistic language. Why is it an issue? So from my point of view, there are a number of issues and opportunities for misrepresentation when we use certain words. And so what we're trying to do is to try and protect the what we mean by things, essentially, and make sure that when we're communicating, in this case, futures, that the decision maker understands the level of uncertainty that we have about something. So we communicate uncertainty because it helps decision making. We communicate it because it helps manage expectations, and we communicate it to retain confidence in the science and analysis. Okay. Also, we've had some significant failures in the past. Let's be clear about that too. And the Butler Review a few years ago, when speaking about some of these intelligence failures, said that if intelligence is to be used more widely by governments in public debate in future, those doing so must be careful to explain its uses and its limitations. And so these are really good guiding principles that we need to adapt and respond to. Okay, so the main point I want to make is that we all instinctively interpret probabilistic language differently. So if I say to you a realistic possibility, what is that? Is that a 20% chance of something happening? Is that a 60% chance of that happening? And so the principle here is that we need to restrict ourselves to a smaller number of terms, and only those terms that are distinct, separate, and easily distinguished, and where we don't stray into using other terms that can be ambiguous. And then we have this other issue of how do we avoid this trap of spurious accuracy? I can't say with any degree of certainty that something's 67% true or likely to happen. So we can't pretend that this is precision in that sense. Let me try and illustrate it. So there's been different studies about what people mean by their words. So if I said to you, how often is often? Well, is it 78% or is it 74%? So I think you get the idea. And when we look at these studies, you'll see that there are fairly big error bars around these percentages for these probabilistic terms. And you can see here we've got a whole range of different terms here, from almost certainly, highly likely, down to sort of probable, or better than even, or improbable. These are words that can cause confusion when we write up futures work. So I just wanted to show you this, which is the government's approach for how we deal with a probability in writing assessments. So you can see here that we have some words that have been sort of the approved words, if you like. It does make the written product a little clunky sometimes because you're sticking to these words. But when you see an assessment and it says there is a remote chance of something, there's an agreed range here. And when you say that's a realistic possibility, there's an agreed range. And you see that there are gaps between those ranges. And that's because of this trap of spurious accuracy and trying to avoid that. And then we can see, you know, the other terms that are used there. So that's the yardstick. And this was, gosh, it came into effect, was it really back in 2018? Before that, we had a slightly different version that we used in defense intelligence. And this has been adopted across the assessment community since then. And I wanted to make sure that when we're doing science and technology features, this is not the only way that we describe stuff, by the way, but it's something that we need to be aware of if we are giving information to a decision maker who's used to this language, because they will interpret it in a certain way. So the other thing that we need to think about is that the yardstick is really talking about the likelihood of events or outcomes, not other forms of uncertainty, and we need to be clear about that. It communicates what your assessment is, but not how sure you are about it, which is confidence. And so there's been some other work on confidence, and there are some exceptions, as I said, when it comes to things like imagery. So confidence can be looked at in different ways. I won't get into that today. But I thought it would be fun just for 2 minutes, just to give this a quick go. So if you've all got a pen and paper or your laptop, I would like you to have a look at the following image. And I would like you to write down, what you think the image is. So it's an object. I want you to write down what you think it is. I'm going to show you some other images, which will either confirm or deny your sort of hypothesis, if you like. So I want you to write down what you think it is, and I want you to write down a probabilistic term from that yardstick. So if I go back, so I want you to use one of these words. So it's okay to say you think it's an elephant, but you know that it's but it's unlikely to be an elephant, but it might be an elephant. You know, you can say that if you want. So let's go back to the image. Here's the first image. So based on that, I want you to write down, commit to what you think this object is. Okay, and I want you now to use a term associated with your assessment there. So if you think it's a snooker table, it's highly likely to be a snooker table. That's fine, and we'll go from there. All right. Now, here's the second image. I want you to think about, has this changed your assessment of what you thought what your hypothesis is for this object? Yes or no? Has it changed your mind? Hands up for yes. Okay, hands up for no. Okay, smashing. So about 50-50 on that. That's really interesting. If you want to, you can now write down a probabilistic term for your current sort of a level of certainty around that object. All right, here's another one. It's the same object. Right, who's more certain? Good. Who's less certain? Great. So we have new information coming in. We're going back to that radar analogy. We're scanning 360. We've got new information coming in. It's being refreshed. We didn't expect this to happen, but we've suddenly got some new information. And we need a probabilistic term to describe that. So which term would you use at this point? Yes, based on the three that you've seen so far. Okay. All right. So here's your last chance, I think, to look at that. So which part of the yardstick are you on now when it comes to this? The certainty that you have around your assessment. Okay. Here's another image. Has this changed anyone's assessment again? Anna, yeah? No? You're comfortable? You're less certain now. All right. So again, if you need to change your term, here's your options. And then here's another one. Same object. Yes. Yes, I'm very sure. There are certain people who have a particular hobby that might know what this is, you see. So if you come into this as a specialist in this particular thing, you might immediately interpret this in the correct way, or you might not. Is anyone more confident based on this image than they were previously? Okay, so your level of certainty has gone up, Ryan. What's the probabilistic term that you would use for this now? Okay, all right. Right, okay. Got you. Okay, right, last chance then. Oh, not quite. Here we go. There's another piece of the puzzle. Does this change the price of fish for anyone? Yeah, you've changed your assessment. Okay, so we're doing the scanning where we're filtered down to a range of images, and it's changing our understanding of what the thing is. And we need to describe this with some language that describes the uncertainty and not even the confidence of our assessment. Okay. Last chance then. What do you think this is? I think Ryan knows what this is. A motorbike? Not quite. Okay, good. Right. So here we go. This is what we're looking at. So I guess for me the point here is that There are different ways of interpreting information. Sometimes we need to change our assessment as we get more information throughout the process. If we start that scanning process, sometimes we need to revise it. Sometimes it's about filtering. And we need to be able to describe that on the journey. Now, if at stage 1, you were in an assessment team and you had to inform the Prime Minister what this thing was, how many people would have got that right at guess 1? You got it right, guess 1? Yeah, okay. Yeah. Okay. You're kind of there, but without a bit of precision. How many people, having made an assessment for stage 1, after stage 2 or 3 would have gone back and thought, I've given the Prime Minister the wrong information? Okay, chunk of us. And how many people feel that do you feel that the probabilistic terms were useful at each stage? Okay, so yes. So it reflects our level of uncertainty. And I think one of the dangers that we have with futures is that we can be either too binary about things and too overconfident, or we don't know the language that we need to use to describe it. Go ahead.
Yeah,
Yeah.
And these aspects would be quite certain, this based on the images and so on.
Yeah.
I don't know this target, so but so it's a little exciting.
Right. But it's interesting that your lens that you're putting on this, because you're not familiar with this, we come at it with a certain paradigm. Each of us we have our own lenses on things. We interpret things in a different way, which is why I think the multidisciplinary teams, the diversity of thinking, different age groups, different different nationalities, different perspectives on the thing is really valuable. I mean, looking back, I heard a really interesting talk about the red teaming, going back to wargaming, the red teaming work during the war actually, and some of the most productive and insightful people that the British used were actually not who you would think at all. I think a girl that works on a farm was probably the most useful red teaming member at that time, which is not what you'd expect at all. Yeah. Yeah. Great. Well, that was all I wanted to share with you. There are other things or more videos, but yeah, any questions? And I'm sorry, we're right on time now, I think. So.
Then you can keep the discussion going during the break.
Questions for Bill, please.
Thank you. So I think that was interesting to look at on the probability and its description. And I'm sure you sort of made it simple and interesting. But that made me think about sort of my financial services, global markets world, or insurance world, where we'd also use the loss severity. That means we always talk about tail risks, okay, which is those things that happens in 5% or less.
Yes.
But the severity, what is the context and how bad it could be. Yeah. And I'm curious that if you have also used that to sort of inform the Prime Minister, because even if it's unlikely to happen, the impact is so big that it can't be.
Right. Okay. So are you talking more like a sort of traditional risk assessment where you're looking at sort of impact and likelihood? Is it that kind of thing?
Yeah.
Yeah. So last time I spoke about wargaming, and now I've spoken about futures, and you'd expect us to be completely integrated so that we've got a whole range of future scenarios in in our wargaming. And we do to some extent, but what we don't do as well as we perhaps could is think about particular technology types and the socio-technical bit. But we do that to some extent. So there will be a range of tabletop exercises, games, risk assessments that are associated with judgments that underpin some of this stuff. So if we're saying that technology, if we're saying that left-handed basket weaving underwater in this region is a significant threat to the UK, then there will be a kind of a traditional risk assessment, I suppose, that would go with that report. But they're coming from sort of different areas of the research portfolio, if you see what I mean. I'm not sure if that answered the question, but I think we do that to some extent, but not routinely, actually. So, not routinely, because that tends to be done on known things. So, like the Cabinet Office has its own national risk assessment. They're on known things, and then something happens that isn't known. So, I'll give you an example. Do you remember the Icelandic volcano that went off a few years ago, and then it caused travel chaos because of the ash in the atmosphere, and planes couldn't fly, and it was actually much more disruptive than people had realised. That Icelandic ash was not something in the national risk assessment until it happened. It might have been in the annex where they said there were things that could happen, but it wasn't. The next year it was, right? So that was kind of a reactive thing. So the point I suppose you're making is we need to make sure that our futures work is also providing a kind of a risk assessment in a language that people will understand around impact and probability and likelihood and so on.
Thank you. Well, final question, quick one, before we go for the break.
My first question, I think, to Fergus is, do you ever go back, let's say, 10 or 20 years and look at your register of different, technologies and compare them to where they are at the moment?
Yes. Yes, we do, but not as much as we should. Okay. So doing success sort of like results analysis is not something we tend to do as often as we should, but we have. And the reason we have is because we sometimes have to justify the investment that we are making in things that aren't necessarily producing output in the physical output, like widgets and things. Sometimes it does. So every now and again we'll get a question, which is, why are you writing a story, or why are you producing a video? So tracking that back, we have a thing called the impact machine in Dstl, where we have stories and we can track back. I actually have a video, it's a hidden slide here, but we've run out of time, on something called Dragonfire, which is essentially like a Star Wars laser weapon, and we're tracking the development of that. So there are a range of things that are in the current research portfolio that came from futures years ago. Synthetic biology is one. We have a whole research program around synthetic biology. Quantum obviously has been tracked for years and years and years. And there are a range of other things, actually, some of which I can't talk about, but came from the futures program and are now mainstream research portfolio outcomes. So yes, we do that. Sometimes we have to do it, but we should do it more.
Okay, great. And my other question is, how do you actually identify weak signals? Was hidden in one of your slides. Weak signals?
Thank you. So, yeah, the reason why, when I was saying we were looking for an AI tool that could assist us with exactly that, and we went to market 3 or 4 years ago, looked around at what was on the shelf, we were not finding something that could really find those weak signals, or at least often enough that it would be useful. It was at that stage with the off-the-shelf stuff, it was more productive to do it by hand, even though the body of information was so large. But then through a recommendation from a colleague at Dstl, actually, we came across this company called Graphian, who've been looking to do that based on a document management tool that they've been building for large corporations where there were millions of documents. And somebody was asking a generic query of that database to try and distill a narrative, a weak signal, if you like, out of a database of information that they held internally. And we looked at it and said, hang on, we can turn that to the business of horizon scanning and technology function. That's what we're using.
Perfect. Thank you so much for your answer.
Thank you.
Okay, so now we have a quick coffee break, and we are going to be back at 11:20. 5 minutes overtime there. But yes, 11:20 back at this room, and we are going to keep on going with Najib's presentation. Thank you, folks. Coffee and snacks are outside.